We've got our two functions here, f of x equals 3x plus 11 and g of x equals 5 times the square root of x minus 1. And we want to find each of these compositions. So first of all, this here is f composed with g, which is the same thing as f of g of x. So our inside function, I like to start with that one. So we have f of, and then g of x is 5 root x minus 1. And then take our function f and use this as the input. So that input right there, that's now x, okay? And so we get 3 times that input, 5 root x minus 1, and then plus 11, okay? And we can go ahead and simplify this. This is 15 root x minus 1, and then plus 11. So there's our function. We'd like to also state its domain. So, of course, our x is being plugged into g first, and so the domain of g is what we kind of need to work off of. So it's taking a square root of x minus 1, so we know x minus 1 has to be greater than or equal to 0. And that, of course, means that x has to be greater than or equal to 1. Okay. Now, looking after we plug that into f, well, f doesn't seem to add any other restrictions because it's just a polynomial, and it's just a linear function, and so our domain does not change. So that's our only restriction for our domain, and so our domain then is just the interval from 1 to infinity, and we're including 1 because x can equal 1. For g composed with f, we're just doing this in reverse order, so we're doing f first and then g. So for f, well, f of x is 3x plus 11. And now we're going to go and use that as the input in our g right there. Okay, and so we get 5 times the square root of, and now our input x is actually the 3x plus 11, so 3x plus 11, and then minus 1. Now this we can of course simplify. We've got the square root of just 3x plus 10. For our domain, f of x, there's no restrictions on that. Okay, we can plug anything we want into this linear function. However, after we then plug that into g of x, we've got this square root. And we know that anytime you have the square root of anything, then that input of the square root has to be greater than or equal to 0. Well, now we just need to get x by itself. So if we subtract 10 from both sides, we get 3x greater than or equal to negative 10. And then divide by 3, we get x greater than or equal to negative 10 thirds. And so our domain in interval notation is our negative 10 thirds to infinity. All right, finally, for g composed with g, these always are a little bit confusing when you're first working with function composition. But we can follow our same process. Okay, this inside function g of x is 5 times the square root of x minus 1. And now we are using that as the input of g. So in this spot again for x. So we get 5 times the square root of, and now that input x is this whole thing, 5 root x minus 1. And then we have another minus 1. All right. So this is our function, and there's not really anything we can do to simplify this, but we can find our domain. We need to, of course, be able to plug our x into g of x. So we have, again, x has to be greater than or equal to 1. That was this same work that we did up here. So we have that restriction, but then we also have this thing that we're taking the square root of. And so that has to be greater than or equal to 0. So 5 root x minus 1, and then minus 1 has to be greater than or equal to 0. And, well, now if we add 1 to both sides, then we get 5 root x minus 1 is greater than or equal to 1. Divide both sides by 5, we get root x minus 1 greater than or equal to 1/5. Well, now we can square this and get x minus 1 has to be greater than or equal to 1/5 squared, which is 1 over 25. And then finally adding 1 to both sides, we get x actually has to be greater than or equal to 26 over 25. That's just getting our common denominator there. So this is what we actually have to have true. Now notice that if x is greater than or equal to 26 over 25, then it's certainly greater than 1. And so it turns out that that right there includes all the restrictions that we need. And so our domain is simply the 26 over 25 to infinity. Okay, and now for part B, we just want to evaluate f of g of negative 2. So f of g of negative 2. Well, we can find g of negative 2, so let's go ahead and do that first. So g of x is 5 root x minus 1. So g of negative 2, well, that's 5 times root negative 2 minus 1. That's 5 times root negative 3. And this is the square root of a negative, which is undefined. Undefined. So we are already done then, because, well, we of course can't evaluate f of g of negative 2 if g of negative 2 isn't even defined. So this is undefined.